In this video we have the integral of the natural log of x quantity squared. If you want to give us a try, go ahead and I'll be right back. I'm going to use integration by parts on this one, and I'm going to do another problem that I've probably done before in another video, and I'll use it in this particular problem here. So let's look at the integral of ln of x dx. It's already worked out here, but let me show you the formula. This is your formula for integration by parts, the standard formula. Integral of u dv equals to uv minus the integral of v du, or sometimes you'll see it in this form, the way I have it here in blue. The v prime is of course dv over dx, so then that cancels, you get dv there. And over here u prime is du over dx. We rewrite it, the dx cancels, this is just du. So you have the different forms. So let me go through this quickly here. I let u equal to ln of x, so du is equal to 1 over x dx. So for integration by parts, we need to give the function 1, or the u function, which in this case is ln of x, and then we need a dv function. So you can always multiply any function by 1, it doesn't change, and so here I have 1 times ln, so I can put a 1 here. U is equal to ln of x, so du will be the derivative of ln of x is 1 over x dx. dv will be 1, or 1 dx, so the integral of dv, or 1 I should say, is x. So then we have the setup here. U times v is the first part of the formula right here. ln of x of course is u and the x is v, but anyway this is the product uv here in reverse order here, and then minus the integral of v, that's this one here, it's x, times du dx, so that's this one here, and that's this. The x cancels out and we get the integral of 1 dx, which of course is x, and then you got the minus. So that's how we get this. So then we go back to the original problem here. So kind of similar here, except this has a square. So it's the natural log of x quantity squared. So here we have an option, and I'm going to apply integration by parts. I'm going to let u equal to ln of x quantity squared. So again, we need two parts, u and v, and then we use the formula. And then du will be the derivative of what I have on the right side. So again here, general here, 2, and then this will be ln of x. Subtract 1 from the 2, so we just get ln of x. And then using the chain rule, the derivative of ln of x is 1 over x. And then we need a dv. dv will be the 1. So the integral of this with respect to v on one side and x on the other side is then v equals 2x. So then we use the formula for integration by parts. And I'm not using the abbreviated form or the DI method here, because this is not too bad. The first part of the formula tells you multiply u times v. So u and v. And I'm going to put the v first. X here, and then the u then will be ln of x, quantity squared. And then it's minus, and that'll be the integral of v. So v is x, right here. And then that's going to be times du. So it'll be 2 ln of x, and then 1 over x. And then I got dx here. So that comes over here also. So notice here, this x and this x will cancel. So I rewrite the first part of the answer, x times ln of x quantity squared. This will be minus. I'm going to factor out the 2 here, and I'm left with ln of x dx. So at this point, you can just do this integral using, again, integration by parts, and I did it at the beginning of the video. So I'm just going to write the answer here, x. This is going to equal then to x. So I've got x then times ln of x, quantity squared, and then it's minus 2 times the value of this integral, which we calculated earlier. And in the parentheses, I just put the answer to this part here. This is x ln of x minus x. And then we have the constant of integration. And this is basically your answer right here. Now we could multiply through by negative 2 here, so we could write the final answer as negative 2 x ln of x, and then negative 2 times the minus x could be 2x. So this could be x ln of x quantity squared minus 2x ln of x plus 2x. This would be your answer. That will show you another way that you can also approach this. So let me just clear this. And if you're satisfied with this, then this is the end of the video for you. But I'm going to give you a little bit of bonus here if you want to see it. So this will be a standard U substitution here, the other option. So I'm going to let U equal, instead of letting U equal to this whole thing in the method of integration by parts, I'm just going to let U equal to ln of x. So here I'm using a standard U substitution. So this will be du derivative of ln of x is 1 over x dx. So I'm going to transform this integral into one involving the variable u. So dx is equal to, multiply both sides by x here, I get x du. So what I'm going to do here is this. This will be the integral. Ln of x will be u. This will be u squared. And the dx, I'm going to replace it by x du. But remember, I have to have it in terms of u. So from here, using your definition of log, I can rewrite this. Then this space is e here. I can say that x is the same thing as e to the u. That's going from natural log, or log form, to exponential form. So right here, this x can be replaced by e to the u. Now, the dx, I'll put it here, replacing this dx by e to the u du. So e to the u here, and then du. And then you use the integration by parts again. Here I'm going to use the abbreviated form. So this will be derivative and integral. So it works this way. I'm going to differentiate the u squared, so this will go on the left side. And I'm going to integrate the exponential e to the u. So we take the derivative of u squared, will be 2u. Take the derivative again. That'll give me a 2. And the derivative of a constant is 0, so once I get to 0, in this case I can stop. And I put my signs on the far left here, plus, minus, they're going to alternate, and plus. Now on the right side, e to the u, the integral just gives me e to the u, so that's easy. E to the u, e to the u, and then we multiply along the diagonals here. So the first part of the answer in terms of u, now we still have to go back and change to the variable x, but here I have u squared times e to the u. So this will be u squared times e to the u. And the next one, next diagonal goes this way. So if we went this way, take the sign with it, with that product, so it stays plus. And now the next one, again diagonal, this one's going to be minus 2u e to the u. And then another integral here, e to the u. And then this time it's a plus, so we'll multiply by 2. This will be a plus 2 e to the u. Finish with the integration. So we add the constant of integration there. So again, diagonally, u squared e to the u, the next one, minus 2u e to the u, the next one, 2 e to the u. And after that, I would stop here. 0 times e to the u, that's going to give me a 0. And the integral of 0 or a constant is going to be a constant. So we stop there. Now all we have to do is go back to the original variable. I have a u squared here, but remember u is ln of x. So I just write ln of x, quantity squared. And then we have e. So let me put it up here so you can see this. It's e. And then the u is ln of x. So the base here is e, and the base of the log here is e. That always gives you the argument here of the log, which is x. So e to the u is x. I'm going to put it out in front. So it's x here. And it's minus 2. Again, you have an e to the u, which is the same thing. That's x. And then the u, ln of x, I'll put it on the right side, plus 2. Again, e to the u by itself, that's again x, plus the constant of integration. And that should be pretty much the same thing as I got previously using the standard integration by parts with u equal to ln of x quantity squared and the dv equal to 1. Should have gotten the same thing. So there we have it. Thanks for watching. We'll see you next time.